A reflection. A reflection can sometimes be nicknamed a flip because you take a shape and flip it over. In order to know exactly what reflection is being done, we need to know where it's being reflected. So we need what's called a line of reflection. The orientation of a reflection is opposite because it turns everything the other direction. Okay? Let's kind of define the word reflection. What we do, okay, well, it would be using a mirror, but here's, like, it would be like a mirror, okay? But here's our official kind of definition. A pre-image, which is your beginning figure, is reflected over a line to create an image. A pre-image is reflected over a line to create an image. Okay, so this starts with a figure that is shaped like an S. So there's our pre-image. And then it is reflected or flipped over a line. And there's our image. What do you notice about the image of the S? Please put iPods and cell phones away, especially if you're using them for communication. There's nothing to calculate with a calculator right now. Okay, so it's backwards, right? So imagine the line of reflection is like a mirror. You want to draw a line in between them. That shows us where one has been reflected onto the other one. Across, like that's a mirror where it's been reflected across, right? Do you kind of get the idea? Okay, we are going to do another reflection using a picture on a graph. It tells you here what to use. We're going to make a triangle, and our triangle is going to be made with the point 0, 0. So let's put a point at 0, 0 and call that point A. And then point B is going to be at over 2, up 4. So there's point B. And point C is going to be over 5, up 2. So there's point C. So we have a triangle ABC, and that's our pre-image. Okay? We want to take that pre-image and reflect it over a line. So we need to choose somewhere to reflect it. We could reflect it over the x-axis if you want. We could reflect it over a horizontal line or a vertical line or even a diagonal line. That would be harder. So I would say let's just do some sort of vertical or horizontal line. Do we want something that's right on an axis or moved over a little bit? Do you care? Moved over a little? Some of you have different opinions. Doesn't really matter. Here, let's do one that's at -1. So I'm going to say that the line of reflection is at y equals -1. That's the line I chose to reflect it over. Okay? Okay, so now what we do to reflect it is we figure out the distance that that point is from the line. How far is A from the line?
1.
It's only a distance of 1. So we're going to take that point and put it over a distance of 1 on the other side. We're going to call that point A prime. Then we're going to take point B, which is how far from our line? 1, 2, 3, 4, 5. Right? Now here we're going to run into a bit of a problem because that's going to take it off the graph paper I provided, but we can adapt to that. So B is a distance of 5 away from the line, so to reflect that we have to go a distance of 5 away from the line the other direction. So 1, 2, 3, 4, 5 the other direction, so there's point B prime. How far is point C from our line? 3 down to the line, right? 1, 2, 3. So how far do we go the other side of the line to do point C prime? 1, 2, 3 the other direction from that line, so there's point C prime. So then we can draw in our image, and we have just created image A prime, B prime, C prime. Let's list where the points are for those. Okay, where is point A prime? 0, -2. Where is point B prime? 2, and I do believe it went down to -6. Good job. And where did C prime end up? 5, -4, right? So this is interesting. Look, since I just reflected it downward, notice how the x values for the numbers all stayed the same? It was the y values that changed for that one. So what if I had flipped it this way instead? Then what would have happened? The x's would have changed, but the y values would have stayed the same. Okay? Any questions on how to do a reflection? Also, this is an isometry. I forgot to put that on these notes. The reason this is called an isometry is because triangle ABC is congruent to triangle A prime, B prime, C prime. Notice how triangle ABC goes clockwise if I go around it clockwise, but ABC in the alphabetical order goes what direction? Counterclockwise. Notice how the ABC are clockwise, but in this one the ABC are counterclockwise. That helps us tell that the orientation is opposite. It's going the opposite direction. Okay, last one for today. Translation. The nickname for a translation is a slide. A translation needs a vector. If we had time, I would show you a clip from Despicable Me where Vector describes why his name is Vector, which is that he has both magnitude and direction. He's committing crimes with both magnitude and direction, right? Well, that's what a vector is. A vector has both magnitude, which means size, and direction, okay? So a vector can be represented with an arrow. We'll deal with that in just a second. Actually, I'll just say, we'll just write that in here. Represented with an arrow. And that arrow shows us the distance and direction to move. So distance would be magnitude or size, and direction, of course, is the direction you're moving something. So a translation is a slide. You're moving your picture a certain distance in a certain direction, and sometimes we use an arrow to show us what we're doing. Okay? Here we go. The orientation is going to be the same. Good job. The definition is that a pre-image moves a certain distance and direction to create the image. Lots of tessellations are done by translations. Lots of tessellations are done by just taking one shape and moving it around to get the rest of your tessellation. Okay, here's an example of a translation. We have the letter Q, and then we have a new letter Q that's just moved. So we need an arrow that shows where and how far it's moved. So I'm going to draw an arrow from one part of the one Q to the same exact point on the other Q. So let's pick a point. We could go at the top. We could go at the little end point. I think just going from the top of the Q would be best. So I'm going to start at the top of the Q, and I'm going to draw an arrow to the top of the other Q. That arrow represents our vector, and the length of the arrow is how far it moved, and the direction the arrow is pointing tells us the direction that it moved. That is called a vector, and it's represented by an arrow. Okay, let's do one on a graph. We're going to start with exactly the same triangle, A at 0, 0, B at 2, 4, and C is at 5, 2. And we are going to translate that. I could give you an arrow to translate it with. If I were to give you an arrow to translate it with, I would just draw it somewhere else on the graph. So the arrow could be, what was I going to use? Let's see. There's the vector, the arrow that tells you where you're going to move it, or how and where you're going to move it. Now, does that mean that this shape is going to be over here since I drew the arrow over there? No. The arrow simply tells us that we're going to move this shape to the left 3 and down 2. Okay? Another way of showing that besides using an arrow is by using an actual number for our vector. So the number for that arrow would be -3, -2. But instead of using parentheses, I use these ends like as if the ends are an arrow. So like greater than and less than signs. So this translation vector, the numbers mean I go left 3 and down 2. Okay? So we're going to take each of these points and move them left 3 and down 2. So let's start with point A. Point A, left 3. 1, 2, 3, down 2. 1, 2. So there's point A prime. Then point B, I'm going to move left 3, 1, 2, 3, down 2. So there's point B prime. C, I'm going to move left 3, 1, 2, 3, down 2. So there's C prime. There's my image. Where are the numbers for my image? Where are the new points on the graph? Help me with it. Okay, so -3, -2. And where's B? From 0, 0. 1 up 2. Good. And where's point C move to? It's actually a positive over 2 and then up and down 0. Some of you are kind of switching the x and y values a little bit. Okay. This one is also an isometry because the image and the pre-image are congruent. So triangle ABC is in fact congruent to triangle A prime, B prime, C prime. And the orientation is the same because if you go around it, look, I'm going clockwise on both of them. Notice how the letters are clockwise on both of them? Okay, good. Okay, that's the end of our notes for today.